In a video I recently made on binary, I received many comments from people saying that I spoke the numbers in binary incorrectly. In binary, this number, for example, represents this many things, but I referred to the number as 101 rather than 101 or 5. Now, this wasn't a decision I made lightly. In fact, it was the hardest part of the entire video for me to decide on. When you speak the words 101, are you referring to the amount of things represented or the digits representing those things? It may come as a surprise to many people who believe either way, as it did to me when I researched for that video, but there's no consensus on this. Nowhere in the math or the computer science world is there a consensus. Everybody thinks that there is, and it's always the way they do it, but there isn't. Now, in my experience, it's always been far more common for people to use phonetic spoken pronunciations to refer to the amount of things, and then simply speak individual digits if you're talking about a non-base 10 number system. So this should have been spoken 1, 0, 1, or 5. Now, this basically implies that the concept of a number is independent from its numerals and its radix. This, in binary, should be verbally referred to as 5 or 101. While the same digits in base 10 should be read as 101, or in hexadecimal should be referred to as 257 or 101. The other side of this argument argues that numerals should function the same as letters or words do, that you read whatever is written down, that 101 refers to the digits on the paper rather than the value they represent. 1 in the hundreds column and 1 in the ones column. Now, there's a big problem with this, and here's where it all becomes really confusing. If this number is in binary, then this digit here no longer indicates a single 100, but a 4, or rather this many things. So by that logic, using the term 101 just doesn't fit here, right? And therefore the read as it's written method is nullified, right? Well, maybe, but no, the original problem is still present. If we use the speak as it's written method, then 100 is just whatever is in the third column. Therefore, 100 in binary is referring to this many things. And in that case, there is a 1 in the hundreds column here, regardless of how many things 100 is referring to. I like to call these two methods read as it represents or read as it's written. There's really no logical reason that saying 17, for example, has to mean this many things, as opposed to indicating a string of digits consisting of a 1 followed by a 7. The former approach indicates that the number 17 always indicates this many things. That's the read as it represents method. And it's represented this way in base 10, this way in binary, it looks like this in octal or this in hexadecimal. The spoken word 17 is not indicative at all of what's written down, only the value. The latter argument, the read as it's written approach, indicates that if symbols representing the amounts change, then so should the words that represent said amounts. We've arrived at the words that we use to represent numbers by working backwards from the digits as they were written down. 25 very clearly indicates a 2 and a 5. Now, going by the read as it represents approach, octal would have this be read as 31, despite the fact that there is neither a 3 nor a 1 represented on the sheet. It's telling us to basically impose vocabulary that was derived from a base 10 system onto number systems that aren't base 10, which has these confusing results. Let's say in Spanish, even in base 10, this number is pronounced 31, but it still represents this many things. So is it fair to say that Spanish speakers or speakers of any other language are wrong when they don't refer to this many things by saying 31? If not, then why is it fair to say that people using different radix-based number systems are wrong? So, of course, that's not to say at all that the read as it's written method isn't complicated, because it brings up similar problems. The read as it's written method means that when you say the number 31 in regards to octal, you are talking about this many things. And if we're talking about hexadecimal, or numbers with a base higher than 10, which use capital letters such as A, B, and C, how do we possibly refer to these numbers? Would this be 700 BD3? What about this hexadecimal number? Is this pronounced AD4? And if so, does that mean 84 or 84. Both of these exist in hexadecimals, so there needs to be some way to differentiate between the two. Now, I could go on and on about how confusing this gets, but to wrap it up, let me just explain why I chose to use the method that I did for my video on binary, which was the read as it's written method. Oftentimes when I try to explain how binary works to people, I say 0, 0, 1, 1, etc., and many people fail to understand that this is still a counting system. They simply hear me saying 0 and 1 and they think it's a pattern that randomly applies to a value like Morse code is. I wanted to explain and make it very clear to people that when using a radix other than 10, the entire concept of what a number is changes. Many people appreciated this, but many were confused because, again, is that what counting up in binary actually sounds like? Is this 1,000,001? Or, well, nobody knows because there is no real answer. This isn't a problem with math, it's a problem with language. Math doesn't care what we call numbers, nor does it care when we decide to add more digits or what base we use. Math is only concerned with values. Numbers and digits and radix and conversion methods between them are all for us to keep track of them and relay them to other people until we develop the ability to think of any value without needing numbers to keep track of them. This problem will likely never be solved. So until then, just make sure you and the person you're talking to are on the same page.